Hello everyone, hope you're all doing great today. Welcome back to my YouTube channel Data Science Galaxy. Today in this video, let us explore the exciting world of databases and SQL. Do you know, without the knowledge of a database and SQL in particular, a data scientist profile is incomplete. Today, every aspiring data scientist must learn SQL. SQL stands for Structured Query Language. Is nothing but the language of the relational databases. We use SQL to create, to access, to retrieve and to modify data quite often. If you're wondering why SQL is a must-have skill, then watch this video till the end for definitive information. Let me start off by giving you 2 or 3 points that is compelling enough for you to start learning SQL if you are not already done so. First point. More often than not, in many data science projects, you are dealing with huge volumes of data which are residing predominantly in the relational databases. SQL provides an efficient way for you to deal with such voluminous data. That's the first point why you must learn SQL. Second, more often than not, in data science projects, you have to understand your data set thoroughly. SQL again is an elegant tool which will enable you to apply several techniques on the data for efficiently extracting meaningful and actionable insights for several business imperatives. Third point, last but not the least, SQL is quite easy to learn, which enables you to increase the chances of job prospects. In summary, allow me to say SQL is an integral part of data science projects today and is the foundation of data science itself. Now let's get into the details of what database is and what kind of operations that one can do on a database. Let's start off by answering a question: what is a database? Database is nothing but a repository or computer files which are optimized to store data in a secured manner. This data is made accessible to concurrent users and applications requiring access on the data. Before we understand the typical functions that can be performed in any relational database management system, it is imperative in the database world to understand 2 sets of commands, namely DDL and DML. DDL stands for Data Definition Language and DML stands for Data Manipulation Language. Together, DDL and DML forms the language of the database. Let us now understand DDL in greater detail. DDL is everything to do with the definition or defining the structures of the database. Namely, you could provide definition for database itself in terms of what the schema of a database is. You could define the tabular structures. You could define about the constraints, users and the privileges and the database. Some of the examples for DDL set of commands are create, drop, rename and alter. I shall talk about these commands in greater detail and also use these commands to demonstrate in detail later in the video. Let's now look at DML. Stands for Data Manipulation Language. It is used for manipulation of the data as the name itself suggests. The examples are insert, update and delete. We shall again talk about later in the video how these commands work, what each one of the commands actually mean. The most frequently performed operations on a database are popularly called CRUD Operations. CRUD stands for Create, Read, Update and Delete. I shall demonstrate this in the detail later in the video. Database has a specific hierarchy. In this slide, we shall understand the hierarchy for several database objects. Realize database objects include tables, stored procedures, views, etc. I am going to talk about the databases and the tables in this slide. So we shall start with defining the schema of a database. Then inside the database, we are going to define a table. Table could typically be a structure which will have, let us say, employee name, employee address, age, salary, etc. There could be multiple tables inside a database. For each of those tables, we will have what are called records, which are nothing but the values for each of the variables in a particular table. So the hierarchy is database comes first. Beneath that we have multiple tables in the data set, and each table contains several records. In a short while from now, we will be moving on to the most exciting part of this video, and that is hands-on demonstration of application of several SQL constructs onto a database for deriving meaningful insights. For demonstration purposes, I am going to be extensively using in this video a popular free tool called SQLITESTUDIO. There are other tools if you are interested to explore, for example, SQL Server Management Studio from Microsoft, and then there are MySQL. There are free tools available out there. Please explore that. So I'm going to use SQLITESTUDIO, the version 3.2.1 for demonstration. Here is a snapshot of the SQLITESTUDIO environment for familiarity. As you can see, it has what is called database pane on the left hand side of the screen. This is where basically you are going to create a database. Underneath the database, you are going to add several database objects like tables, views, etc. And on the right hand side, you could see what is called a SQL editor. This is where you are going to write the actual SQL code. Beneath that, you find what is called output pane, also called grid view. This is where you see the output after executing every single line of SQL code written in the SQL editor. Below that, you see what is called execution status window. This is nothing but it shows whether successfully you have executed the SQL executable line of code or not. If there are any syntactical errors in this window, it will display. Friends, here is the moment you have all been waiting for. This is the SQLITESTUDIO 3.2.1 interface. I have already created a shortcut on my desktop and also have pinned it to my taskbar. So this is the interface I am going to be interacting with for demonstrating doing the CRUD operations on the table in a database. The first and foremost, we have to go ahead and create the database. Then I'll go ahead and create a particular table. Of course, realize you could add multiple tables in a database. I'm going to create a single table. Then on that table, we are going to create some records, rather insert some records into the table, and we shall see what are the operations we can do on that table. The CRUD operations basically that we talked about. So how do you go about creating the database? Do you notice on the left top a database menu at the top level? I click this. It gives me option to add a database. I'm going to click add a database option. Then by default the database dialog opens and the database type is defaulted to SQLite 3. If I were to click it and show you, it has other options like SQLite 2, SQL Cipher, etc. But I'm going to default to SQLite 3. Realize SQL Cipher is for storing the passwords. Then I have to choose a file, and there is a plus icon next to this text box here. So if you see, create a new database file. If I click this plus icon, it opens a dialog box and it allows me to choose a name for this database. Let's call it as demo.db itself, and then I'm going to call that as demo. Notice it has appended .db as the extension, indicating it is a database. You also notice in the name text box, demo is already coming and sitting here. So just I'm going to add underscore SQL just to make sure it is a SQL demo, just for better identification. So before I say OK, I'm going to have the options enabled. I'm going to go with the default options and I'm going to test the connection. Yeah, the connection seems to be OK. The moment I say OK, notice that this demo underscore SQL that we have created as the database name would come and sit under database here. Yes, we have the database coming under sitting in this pane. So I click this, right click on this, and there is an option to connect to the database. Once I connect, the database is created and connected. Notice under this we have the two objects under the database, tables and views. What we are going to do now is to add a table. Now let's go ahead and create a table. Let's create an employee table with the employee name, age, profession of the employee, and salary of the employee. Just a small table for us to play around using the operations later. How do I do creating the table? I go here and I right click and select the option create table. Notice you will get all that is required to go ahead and create the table. So where you can add columns using this area, and you can first name the table. First and foremost, let's go ahead and name the table. Let me call emp underscore table as the employee table, and do not select the option without row ID. See, usually in the database context, what we do while creating a table is we also create a primary key. For now, I'm not going to create the primary key. I'm going to go with the row IDs to uniquely identify every record, which becomes then the primary key. Also, having a row ID helps you to auditing when you want to delete the records or keep the log of what happened in the database. Row ID would be a good help. So I've named the table. Let us make it as not TABL, or let us make it as a TABL itself. So to add the columns, what I do, anywhere in this area where you see nothing here, double click. Notice it opens a column dialog. So let's just create employee name as the first column under the table, employee name. So I'm going to select the varchar as the data type, saying it is alphanumeric in nature. And let us say we have 50 characters in length, and I simply hit the enter button on my laptop. So we have added the name as one of the columns in the employee table. Let us add few more columns. Let us call this as employee underscore age. Obviously, age is a numeric data type, so let's give it a 3 in length. And let's go ahead and add another variable, rather column for profession. Let's call that as employee underscore prof, emp underscore prof, and this is again a varchar, and let's say we're going to give her 50 characters in length. So let's just add another column. Let's call that as emp underscore salary. Okay, so this is again numeric in nature, and let's say this is a 7 digits in length, and be done with it. So we've created all the columns that we wanted for the table called emp underscore TABL, but you have to persist this table so that it gets stored under this objects called tables under the database created. How do you do? Look at this icon here. If I move my mouse over it, it says commit structure changes. Notice when I click this, you will get a pop-up window where you get an exact SQL syntax for creating the table. So what do you mean? Just watch out. Okay, so this is exactly the create table command that you would use for creating the table. Of course, I used the other way of keying in my employee name and selecting the data types, etc. So I could have as well written this construct, SQL construct, to exactly create a table. So here create table are the two keywords you must use. Emp underscore TABL is my table name. It could be anything. As far as possible, give the meaningful names. Rest of it you would know we have created the columns. Notice the moment I say OK on this emp underscore TABL comes and sits under tables object. Notice that. So now we can see here we have created a table called emp underscore TABL. We have created 4 columns under it. These are the columns we have created. So next, what we will do, we shall go ahead and insert some records so that we could apply some CRUD operations on the table for better understanding. How do we go ahead and create records and insert into the tables? For that, watch out. I'll go to this tools option, and I have to get a new SQL editor where I can write the SQL constructs or do the SQL programming. See what happens the moment I click open SQL editor. You get a real estate area and you default to tab called query, where you are going to add SQL programming constructs here. So we have created a table with these 4 columns. Before we do anything on the table in terms of the operations, first is to create some records into the table. So just to remind you, the hierarchy is database, tables, then under this tables we have created employee table, and for the employee table now we are going to add records. How do we add? We have to use the keywords called insert into. This is the standard syntax. Insert into are must keywords. You should not mess with it. So insert into table name. What is our table name here? emp underscore TABL. Insert into table values. Then open and close the parenthesis. Within this, you have to give values for employee name, age, employee profession, and salary. When you say varchar, for some of you who are from, let us say, C programming background, varchar is equivalent of a string. Char continues to be a character. Varchar is nothing but a string. Whenever anything is a string, we have to put it in double quotes. Okay. So here I'm going to put the name. Let us say we are going to call the name as Arun. Just we could give any example. And age is numeric. Let us say Arun is 40 years old. And profession, let us call Arun as a data scientist. Okay. Because that's a string, I'm giving it in double quotes, and salary, let us say whatever the currency is, let us say 100,000. Okay, so now this is the insert command. I'll select this, I'll have to execute this. When I execute this, if there are no errors, then the status will reflect that. If there are any syntactical errors, the status window will reflect that as well. So for executing this, I go here and move my mouse on this. You can see it is executive query, and it also gives you the functional F9 command to run. But I click this execute query now. So notice here it has given the time 0.011 seconds, row effect is 1. Now we have inserted one record. So just to speed up things here, I'm going to copy, paste 2 more times and change the values here. Let us say we are going to call this as Paul, and let us say Paul is aged 45 years, and let us say Paul is actually an IT professional. Shall we do that? Yes, IT prof, let us put it for abbreviation, and let us say Paul's salary happens to be 150,000, whatever may be the currency. So for executing, don't do the mistake of selecting everything. You have to select a particular line of code like this and execute this query. So we have inserted another record. Shortly we'll go and visualize how do we visualize all the records inserted. Bear with me. Let me just continue with the insert command. So let's just add the third person to be, let us say John, and John happens to be, let us say 42 years of age, and let us say John happens to be a business analyst. And let us say John's salary is the highest, 200,000. So what I'm going to do now is to select this and then execute this. Okay, so now we have inserted 3 records with respective values for each of those columns into the table. So how do we visualize? We have to use, remember, the CRUD operations. We have to use now the select operation. So we have created the records. Now we have to read the records. So we have to select. The keyword for doing that starts with select. Okay, star indicating all the records. I'm not specifying any criteria for getting the records. So I'm going to get all the records irrespective of any values in it. Select star from emp underscore tabl is the command for selecting all the records. Let me just run it and show you. Before that, notice here the grid view where I also mentioned earlier, you will see the output. 3 records we have inserted. We will see the table format or a matrix format, the output if there are no syntactical errors in it. Let's do that, shall we? Notice the 3 records are in front of you. Pretty neat. Yeah. So now we can play around with these 3 records. What all we could do, let us go ahead and update. Let us say this IT prof, I've given it as prof for short, make it IT professional. Let us say I'm going to give certain criterion for salary and select based on certain criterion for salary. All those things we shall go about doing it in a minute. Now instead of viewing all the 3 records, how about applying some criterion or criteria on the table and then get a subset of the records matching the criteria? So how about we using salary variable and then have a cutoff for salary or a threshold beyond which we want to see the records? What do you mean? Let's just examine by putting a criterion. So what do you do? Select star from table. This is nothing but M table. As you realize, this gets all the records, but we don't want to get all those records. We want to give the condition. So how do we give? We have to put a where clause. This is called a where clause. It is a must when you are going to define a criterion or a criteria where employee's salary is greater than, let us say, 140,000. So what do you expect when I give this command? Select star from emp underscore tabl where employee salary is greater than 140,000. So we don't get all the records. Watch out. Whichever records match this criteria of greater than 140,000, we'll get them. Let's go ahead and execute this. As you would have anticipated, we get 2 records because Paul's salary and John's salary is certainly above 140,000 and Arun's salary is not. So Arun's record is not shown up here. So this is how you go about applying certain criterion. So realize this is a demo after all, and I've created only these 4 columns. In the real world scenario, you would be having far more number of columns. Let us say 40 columns, 50 columns, 30 columns in a table as the case is. So in that scenario, you would not be visualizing all the columns. You may be interested to look at only subset of the columns. Let us say, for example, I want to view employee name and employee profession for a criterion for a salary. So what I'm going to do, is copy this into the next line just to speed up things here. Okay, so I'm going to, instead of saying star, I'm going to give the variable names. What are that? Let us say I'm going to get the employee name, comma, and I'm going to get employee profession from employee table where salary is greater than 14,000. So instead of getting age as a column, I'm going to get only the name and profession are the two columns that I'm interested to see. Can you see that? So it is not just getting you the columns of interest that you want to see, but also ensuring that the records meet the criteria that you have selected. How about now we update certain columns? So let me just explain. Let us one more time see select star from employee table for the records. So you've got back all the three records. And notice for row ID 2, that is Paul's record, we have IT Prof as the abbreviation. How about we update this record of Paul, or row ID 2, and then we make that instead of calling IT Prof, let's say it is IT Professional. How do I do? I have to use the keyword called update. Don't forget to use this keyword. The syntax is this: update employee underscore TABL. We have to use another keyword called set. So what are we setting? Set the value for employee prof, emp underscore prof. So I'm going to say emp underscore prof is equal to what? Because it's a varchar, I have to give it in double quotes like I mentioned. You should not forget that. Let us call this as, instead of IT prof, let me make it as IT professional. So one word of caution: if you execute this command without giving the criterion, it will execute and fill for all the records. Aaron, Paul, John, everybody, it makes it IT professional. It should, the update command should always be accompanied by the where clause. That means I want to select a particular record which I want to update. So what I'm saying, I want to update Paul's record, that is nothing but row ID is equal to 2. Now you realize why I said use the row IDs. So I'm going to say row ID is equal to 2. So when I execute this as anticipated, for Paul's record alone, IT Prof becomes IT Professional. Let us see if that works. Yeah. See this, it has again taken very less time and it has impacted the change. Let's go ahead and run this to see for ourselves what we mean. Notice here, previously it was IT Prof and now it has become IT Professional. Think about what else you do. See, in the real world projects, as part of exploratory data analysis, you understand the data, and while exploring the data, you would also come up and do something called feature engineering. Sounds familiar? That means to say, use the information available in the other variables in the data set and use in a certain combination and permutation and apply some business rules and create your own variables, and we call that as feature engineering variables, or feature engineered variables to be specific, isn't it? How about we go ahead, alter the table structure itself for the schema by adding another column which is very similar to feature engineering. So let us say I'm going to add another column called tags column. How do I do that? For doing that, I have to use the command called alter table. These are the keywords that you should not miss. Alter table. What is the table that I'm going to alter? Is employee or emp underscore table. What I'm going to add? I'm going to add a column. So I'm going to use the keyword called add, and I also go ahead and use another keyword called add column. What is that column name I want to add? Let us say I'm simply calling it as tags column. And what is the nature of the tags column or the data type? It is numeric. So when I execute, notice here you only see 4 columns. Here also you see 4 columns. It is going to add another column called tags and makes it numeric for the data type. Let's see if that works. Voila. Now can you see here tags? Let me just run it to show the select star from emp underscore table. What do you expect? You expect 5 columns, but the last column tags is not filled. Why? We have not specified anything to tags yet. It is a nullable column. So you could go ahead and make this as non-nullable so that it will always be mandated to enter the values. So let's apply some business logic to calculate the tax. Let us say the tax amount is nothing but, in a certain geography, 30% of the employee salary is called tax. So can we just compute tax value for each of those employees, Aaron, Paul and John, by taking their respective salaries and multiplying it by 30%, whatever is the resultant amount would be called tax. Shall we go ahead and do? How do we do it? We have to use update command. You're right. You have to use update command. Update which column I want to update? Update tax column. Okay, so how do we do this? Update tax column. Okay, sorry, I just got it wrong. You have to update what is the table first, employee underscore TABL, update employee underscore TABL. What do I want to do? I want to set tax is equal to, what is the business rule that I mentioned? Employee's salary, 30% of it, EMPSA all LARY, this multiplied by, let us say 30% is 0.03, and let us see if this works. So what I'm saying is, take the employee salary, multiply it by 30%, whatever is the resultant, fill tax column for each of those employees. Shall we see if this really works? Yes, it has not given any error. That's the good news. Let's go and see for ourselves. Can you see? 30% of 1 lakh is 3,000, 30% of 1,50,000 is 4,500. Okay, it is 0.03 I've given, it is 3%. Let us make it as 0.30. Okay, 30%. Sorry about that, but the calculation is right, but the whatever I meant, I just made a small mistake there. Okay, so now let's go ahead and see if we are able to get this. Now you see, if someone gets a salary of 1 lakh, the tax amount is 30%, amounting to 30,000. So we're able to now not just add a column, we are able to update that column based on some business logic. So what else you do? Think about it logically. When you are looking at again the exploratory data analysis, you want to make use of certain information in the variables and create your own variables. Let us say I am going to create one other variable. Any guesses? You got it right. Let's go ahead and create a variable called a take home salary and then compute take home salary, which is nothing but employee salary minus tax. Shall we do that? Now to add another column called take home income and to compute the values for take home income, what are the SQL commands that I should use and what is the order? Any guesses? Any thoughts? You have to use the alter command first. Next would be the update command. Order should not be changed. Let's see how you do it. Do you want to see? Let's get started. So I'm going to first use the alter command, and the keywords for doing that, or the construct for doing that, is alter table. And let me give my emp underscore TABL is my table name. What I want to do, I want to add a column. So add a column are the two keywords I'm going to add. What is the column name that I want to give? Let us call that as take home income. So what is the data type? What is the nature of the data? Take home income is numeric. Shall we execute this and see if we are able to get the additional column added to the table? Notice here, after tax, a column called a take home income should come and sit if everything is fine. Absolutely yes. Okay. So as I mentioned earlier, let us just use the select command to see if we have anything going on in the table with respect to the new column added. So shall we just do this now and then see what happens? Okay, there is a mistake here because it is not table, so you have to be very specific about what is the name of the table that you have given. There is no E here. Let me just remove that and see if it matches with the exact table name. Voila. As anticipated, there are no values available for the take home income because we have not computed. So how do we compute? We will compute it as salary minus this employee salary minus tax, and we call that as take home income. So how do I use? Like I mentioned a while ago, we have to use the update command. So what are the keywords for using update command? Update is the keyword. What is the table? EMP underscore TABL. Get the name right every time. So I want to set take home income to certain values. So set take home income is equal to, what is the business rule we are applying? We take the employee's salary, subtract the tax from it, whatever is the resultant amount, we are calling it as take home income. So notice it is null now. The moment I execute the first command here, select star from employee table, you will be able to see values if everything is fine for take home income. Yes, we have computed the values for take home income. Let us see what is the take home income. So salary is 1 lakh, 30,000 is the income, take home is 70,000. We have been able to calculate for all the employees successfully. So far what we have done, we created a table, we inserted some records, we visualized all the records, then we nuanced the query and then added some criterion to it, and we said, okay, we visualize all the columns in this. We want to visualize subset of the columns and also apply the criterion, which we did. Then we went about adding new columns by altering the schema of the table. We added tax as the first column. We computed the tax as a percentage, 30% of employee salary, and computed value for tax. Then we added another column called take home income and then computed take home income as employee salary minus tax. We shall go ahead and do a few more things. How about now using some aggregating functions? In data analysis, exploratory data analysis, it's pertinent to ask, okay, what is the average salary? What is the average tax? What is the average income, etc.? Shall we go ahead and try some aggregating function in SQL? Now let's just go about calculating the average employee salary and average take home from the table and visualizing. Shall we do that? So I'll simply say select, that's a keyword. Because I want the average, AVG is the keyword for average. I want average of, let us say, employee's salary. So I'll write it employee's salary. From which table? From my employee underscore TABL. Okay. So let us see this, the average salary. Do you see this? 1,50,000 is the average salary for all the across these employees. And how about looking at the average take home income? Select average. Now the variable that of interest or the column of interest is take home income. That's what the name we have given from emp underscore TABL. So notice average salary, employee salary is 1,50,000 and average take home income is 1,05,000. So this is pretty similar to when you're exploring the data, you ask business pertinent questions and try and seek answers from the data and through the evidence provided by the data. So you could go ahead and explore a lot more functionality that you would do in your traditional exploratory data analysis, even on the database side using SQL. So let me say in summary this. What we have done is pretty parallel to what we would do in exploratory analysis in other development environments or programming environments or statistical packages, to name a few, let us say R environment or R Studio or Python or any other environment. You could as well do all of that and more even on the database side using SQL constructs and SQL programming or the SQL scripts very elegantly, answering several of the business questions and generating many insights for decision making. With this, I've come to end of this video and I sincerely hope you found this video quite useful and it has been worth your while. Thanks for watching. Please leave a like and share with your friends and your network. Subscribe to my channel Data Science Galaxy if not already done so, and stay tuned for more videos on machine learning, data science and videos related to career transition into data science roles. Don't forget to hit the bell for notifications whenever we release a video. This is Manjunath signing off. Bye bye, happy learning and happy sleuthing.